looking at section 6.1, which is on rational roots, and hopefully you remember these flashcard numbers because now we're going to be looking at going totally backwards, totally the reverse of these. So hopefully you know these numbers. So I want you to put the video on pause and I want you to zip through these as fast as you can. See if you can do these in, oh, I don't know, like 10 seconds. You should be able to get all of them. Okay, ready? Go. All right, so there you go. There's your flashcard. So now we're going to have to learn how to go in the reverse of those. Here's one of the things, first thing that we want to try to know is how to do this notation. We're used to seeing something that looks like this, a raised to the n power. What we're going to do now is write this in what's called radical form. All right, so you're used to seeing rational form. Rational form has the power up here in the power position. What's going to happen now is that we're going to look at these powers, but they're going to be fractions. So if we can write these as a radical, that's what we need to look at. The n value that you're going to be looking at is always going to be in the form of a fraction. So it could be something like 1 over 3. So when we have to write it in radical form, we only take the denominator, and that denominator becomes what's called the index. This guy right here is called an index in the radical sign. So what we're going to do first is flip back and forth between rational form and radical form. Let me give you a quick example. If you had to do a to the 2/3 and change that into radical notation, we would take the index, which is the denominator, we'd put the denominator right here, and then we would have a to the second inside of that. Sometimes you're going to see it written this way, the cube root of a, and then the whole thing is raised to the second power. That's the same thing. You could do either form. It just totally depends on what your a value is that's on the inside. But the key that you want to remember is that it's the denominator that becomes the index. The numerator is going to stay put. We also want to remember the power to a power rule. We've looked at this before, where we have one thing raised to another power, and what we said for that was to multiply. A raised to the n times m. We're going to keep that in mind when we do these particular examples as well. All right, so the first thing we're going to do here is go through some of these simple ones and how we come up with these actual answers. Well, if we can remember from your flashcards, we said that 2 to the 3rd power was 8, so now here's how we have to go backwards. The question is going to say 8 raised to the 1/3, so you need to know that 8 came from 2. There's some number out there, if you take it 3 times, gives you 8, and that number was 2. So 8 to the 1/3 is 2. Well, now we get something like 8 to the 2/3. So here's where we're going to use our power to a power property. We're going to break up the number 2/3, the power 2/3, into 1/3 and then raise to the 2. If you remember that when you go backwards with this power property, 1/3 times 2, which is really 1/3 times 2 over 1, gives you the 2/3. So we're splitting apart this power 2/3 into 2 things. One of those things is the piece that we know. We now will be able to recognize that 8 to the 1/3, 8 comes from 2, so in the brackets this becomes 2, and then we'll raise it to the second power, and then 2 squared becomes 4. So 8 to the 2/3 is really 4. 16 to the 1/4, if you can remember what 16 comes from, that comes from 2. Now if you notice I've got a plus and a minus sign here. Every even power for the denominator must be written as plus and minus 2. But this only works if you've got a 1 on the top of that fraction. It will not hold if it's any other value. So for instance, this one, 16 to the 3/4, I will not put plus and minus on that since I've got a 3 on the top instead of a 1 on the top. All right, so let's do this 16 to the 3/4. I'm going to split the 3/4 power up into 2 pieces. 16 to the 1/4 and then raise to the 3rd power. I do that because I know 16 to the 1/4 comes from 2, and then 2 to the 3rd power gives me 8. 16 to the 3/4 equals 8. 64 to the 2/3, I want to split that apart into pieces. 64 to the 1/3, and then raised to the second power. Hopefully you remember that what 64 comes from. There's some number out there, times itself 3 times, takes you to 64. That number is 4, and then I do 4 squared and get 16. Negative 27 raised to the 1/3. This is not a flip it question. The negative sign is out in the front of the 27. So you're asking, or the question is being asked, what is the opposite of 27 to the 1/3? You can look at it this way as well. 27 to the 1/3, 27 comes from 3's, so I'm looking at the opposite of 3, or my answer is just negative 3. Next one is 8 to the negative 4/3. Now I actually have the negative power up above, so this is actually a flip it question. So I'm going to take my 8 to the negative 4/3 and flip it 1 over 8, and when I flip, it's no longer negative, positive 4/3. Now I want to break apart my 4/3 power into something that's doable, 8 to the 1/3, and then raise that to the 4th power. 8 to the 1/3, 8 comes from 2's, so this is 1 over 2, and then raise that to the 4th power, and 2 to the 4th power is 16. So my solution will be 1 over 16. This last one on the slide is negative 64 to the 1/2. Is this a flip it question, or is this like this one where it's just the negative of? Yes, it's just the negative of 64 to the 1/2. Now remember, the 1/2 power is exactly the same thing as looking at the square root of 64. 1/2 power is the same thing as square root of. I know the square root of 64 is 8, so this answer is the opposite of 8, or just negative 8. On this slide, we're just going to be practicing going back and forth between radical form and rational form. On the left side, we've got radical form. So the first one is the nth root of a. If I write that in rational form, the index becomes the denominator on my fraction, 1 over n. And if that n power is even, remember we have to put in a plus and minus sign, and that's only if I've got a 1 on the top. And I write that in note there off on the side. Okay, radical form. 4th root of 256 becomes 256 raised to the 1/4. I then can solve this one. 256 is one of those numbers we're supposed to be able to remember. 256, if you can remember, comes from 4. And since it's an even power and the numerator is a 1, I need to put plus and minus 4. The cube root of 27 written in rational form would be 27 raised to the 1/3 power, and 27 comes from 3. My power was 1/3, that's an odd number. I do not need a plus and minus. 4th root of 81 all raised to the 3rd power. When I write that in rational form, 81 raised to the 3/4. My index of 4 becomes the denominator, 81 to the 3/4. 81 to the 3/4 can be solved. 81 to the 1/4 is the piece that we know. That's 3. 81 comes from 3 to the 4th. And then I'll do 3 cubed and come up with 27. My final answer is 27. I do not need to put plus and minus. It is an even power, but I've got a 3 in the top of the fraction instead of 1. All right, now we're going to go the other direction. We're going to change 32 to the 1/5 into radical notation. Put your radical sign, 32 goes underneath, and the index of the 5 goes out here, 5th root of 32. We can also solve that. We know 32 comes from 2. 11 to the 4/5 in radical notation. The index is 5, and then inside here we've got 11, and then raised to the 4th power. You can either put your 4 on the inside or the outside, it doesn't matter. And we can't solve this one because we didn't deal with 11s. 125 to the 2/3, we can write this one as cube root of 125 and then squared. We can also solve this. 125 is one of our flashcards. 125 to the 1/3 is the doable piece. That becomes 5. 125 comes from 5s, and then I do 5 squared. My final answer should be 25. And the last one, negative 64 to the 1/2 would be the square root of negative 64. And when we are dealing with these radicals, we are not going to bring in I terms. So this one would be no solution when we try to solve this. No solution on this one. This next piece is just solving equations, and we're going to use our radicals to help us solve those. We're trying to get an answer for x. First thing we're going to do is divide out our 6 on both sides. X to the 3rd equals, grab your calculators if you need to, 64. And then we need to get rid of that 3rd power. So to get rid of raised to the 3rd, we're going to raise it again. This is one way to do it. Raise it again to the reciprocal, 1/3. The 3 1/3 power to a power would give me 1, so those cancel each other off. And if I raise to the 1/3 on one side, I need to do that on the other side as well. 64 to the 1/3 is one of our doable values. I get x equals 4. Do I need a plus and minus on that? Hopefully you are answering no to that, since we're dealing with a 1/3 power, and that's odd versus even. The other way that you could write these, after we divide, we've got x to the 3rd equals 64, and then we're going to get rid of raised to the 3rd. That's cube root. So the cube root and the cube cancel each other out, and you're doing cube root on both sides. Same thing, remember radical notation versus rational notation, same thing. And then on this last one, we're going to be putting our answer to 2 decimal places, so you definitely want your calculator here. We have x minus 8 raised to the 5th power equals 100. I need to do something to get rid of this raised to the 5th power. 2 notations, you could write it in either one. You could square root or radical to the 5th root, and then make sure you do that on both sides. The other way that you could write this, x minus 8 to the 5th, and then I need to undo that, so we're going to up it again, raise it again to the 1/5 power. Doesn't make any difference how you write it. It means the same thing, raising something to the 1/5 power. The 5th power and the index 5th root cancel each other out. You're left with x is equal to, x minus 8. Change that for you. X minus 8 is equal to the 5th root of 100. Here's where I wanted to get a decimal value to a couple places. And then the last thing we're going to do is add 8 to both of those. So 8 plus the 5th root of 100, and then hopefully you are getting approximately 10.51. 10.51. Okay, so those are your basics with changing back and forth between radical and rational notation. You'll be looking at page 417 for your homework for this. And if you notice on your homework sheet that you're not supposed to use a calculator for most of them, you need to be able to remember those flashcards. And by the way, did I ever mention what my favorite movie is of all time? The Shawshank Redemption.